Hello, this is Paul Bowman from CAT. I am standing next to an Anubis server with a keyboard and display attached so we can make a presentation of the CAT IP Camera server. We will now show you some brief video clips of the various components of the system. You will first see a video clip of the BBS and its connections to the Anubis and its connections to the camera. We will have a picture of a PoE switch which provides power to the IP camera. The IP camera is actually located outside the office front door, and you will see a quick clip of how we made a connection to the camera by intercepting its cable in the ceiling. Finally, we will show you a clip by walking out the front door and pointing the camera at the IP camera, which we will be demonstrating.
Yeah.
We're now looking at the display connected to Anubis, which allows us to monitor various activities in the system. We are now going to zoom down and take a look at one window. The window you're looking at is a view into the BBS collecting camera frames. You will see an added message for every frame that is placed into cache. The cache memory holds some camera history which is configurable so that viewers who might be starting a little late can view earlier frames than the real time. So that could be, let's say, configured to go back 10 seconds, which would allow you to catch events if you have a slightly slow internet connection to the Anubis or BBS. We are now going to zoom in and start the frame viewing application, which lets you look at the camera stream, which is coming over OTOCN secure protocol. Now we'll type in the command to start the application program. Now we see the login screen, which allows us to access OT cameras. What we need to do is we want to have this logged in the database, so we will first ask the application to start the database by clicking on Start button on the right. Now we have started the server and we will proceed with a login. Now we will hit the login button. And we now have the video viewing screen at our access. If you take a look at the top of the screen, you can see OTOCN mode has been checked. This tells the system to access cameras using OTOCN as opposed to regular camera protocols which are not secure. What we'll now do is we'll now move over And at the top of the screen, you can see the button that says Start Camera. And we will go ahead and press that button. As you can see, we now have an outside view of the camera. We can see the sidewalk outside the door. And what we'll do here is to demonstrate, I will back off the view and you will see me go out the door and in the door while viewing the outside camera. Now we will demonstrate me walking out the door and coming back in, and you should be able to see the frame capture from the outdoor camera. And that concludes our quick demonstration of frame capture. We are now going to quickly show you a TCP dump of OT packets on the network connection between the BBS and Anibus. All of the packets are encrypted. There will never be two identical packets ever on the network. All packets are 512 bytes of content in a UDP packet. So all OT communication is packetized to 500 bytes. That amount can also be smaller depending on the transport we wish to use. On screen now, on the left, you see periodic scrolling of a packet. This is the heartbeat packet between Anibus and BBS, where it changes network conditions and device status. At the moment, I do not have the Anibus pulling any video frames. The video frames are just being cached on the BBS. In the screen slotted to the right, I have a simple application that will pull camera frames. And I will start that, then we'll start seeing a stream of OT packets corresponding to the camera frames. So now what we're doing is, for demonstration purposes, we're pulling frames at a slower than real-time rate. The demonstration frame grab program will do a intentional delay every 100 frames to demonstrate the functionality of the cache. Now we have stopped the capture, and then we go back to just seeing the heartbeat messages. This packet is encrypted again and is unhackable. So all OT communications, whether it be camera frames or process packets or any other communication over OTOCN, moves through this encrypted transport. Here we are showing a frame capture of a heartbeat message. As you can see, it's random encrypted data in this packet. Now we're going to show a less detailed dump of packets. These are simply the heartbeat packets. We are repeating the previous display of packet dump summary. This time we will watch heartbeat messages for a few cycles, then we will start frame transfer. As you can see, the packet rate has drastically increased as we send frames. We'll stop frame capture, and then we'll go back to simple heartbeat. And that ends this simple demonstration of OT transport packets.